Welcome into the Ontario Eye YouTube channel. In this explainer, we're taking a massive, dense list of 50 common Power BI interview questions and boiling them down to show you exactly how Power BI truly works under the hood. If you're prepping for a data analyst role at a tech giant like Google or Microsoft, you've probably seen lists of these questions floating around. But honestly, rather than just relying on rote memorization, we're going to break down the core concepts and their real-world use cases so you can understand them simply and clearly. To do this, we'll follow the actual life cycle of a data project. We'll start with the Power BI ecosystem, move through Power Query, data modeling, mastering DAX, visuals and interactivity, and wrap it all up with optimization and security. Now, the source document we're looking at covers the exact 50 questions asked at top-tier companies, detailing everything from absolute basics to some seriously complex DAX functions. But, like I said, instead of just memorizing disjointed facts, we're going to connect all these concepts into a single, compelling narrative. That way, you can confidently explain the why and how in any interview room. Okay, let's jump right into Section 1, the Power BI ecosystem. It's really interesting how clearly the source splits the workflow here. A super common question asks for the difference between Power BI Desktop and Power BI Service. The simple answer? Desktop is your local sandbox. It's that free application sitting on your computer where all the heavy lifting happens, building out the data model and designing the report itself. The service, on the other hand, is the cloud platform. So you build locally in desktop, but you share, collaborate, and schedule your data refreshes globally using the service. Another massive concept in the ecosystem is how you actually connect to your data. Import mode versus direct query mode. Import mode physically pulls a copy of your data right into Power BI's incredibly fast in-memory engine. It's blazing fast for sure, but it does require scheduled refreshes to stay up to date. Direct query, however, leaves the data at the source and sends live queries every single time a user clicks on a visual. So if your use case is a massive, real-time operational dashboard, direct query is absolutely your best friend. But import mode is perfect for those lightning-fast static monthly reports. Moving right along, Section 2, Power Query and Data Prep. A classic interview question asks for the difference between merge and append in Power Query. The easiest way to think about this is visually. Merge queries join two tables side by side based on a matching key, like bringing customer names into a sales table. It's exactly like a SQL join. Append queries, on the flip side, stack rows of data on top of each other, much like a SQL union. So the crucial takeaway here is knowing whether you're adding new columns from a lookup table, which is a merge, or stacking new monthly sales files together, which is an append. And that leads us to a favorite concept for advanced interviews, query folding. Query folding is essentially when Power Query pushes your data transformation steps back to the source database, like a SQL server, so the heavy processing happens over there, instead of choking up your local machine. It drastically improves your refresh performance. You just have to be a bit careful, because writing custom M code or using certain complex steps can actually break this folding process, and you definitely want to avoid that. All right, on to Section 3, Data Modeling and Relationships. A core concept that comes up constantly is the difference between fact and dimension tables. Fact tables hold your measurable, quantitative data, think sales amounts, transaction quantities, the actual dates things happened. Dimension tables, however, hold the descriptive attributes. They are the who, what, and where, like specific customer details or product categories. A great way to remember this use case is that your fact sales table holds the revenue numbers, while your dimension tables are exactly what you use to filter and slice those numbers. So how do you arrange these tables? That brings us to star schema versus snowflake schema. A star schema has one central fact table connected directly to your dimension tables. Literally looks like a star. Power BI heavily recommends the star schema because it vastly simplifies your DAX formulas and maximizes your model's performance. A snowflake schema, on the other hand, further breaks down dimension tables into subtables. As a rule of thumb, you really want to avoid the extra joins required by a snowflake design unless it is absolutely, strictly necessary for your specific data structure. Now, when you're connecting these tables, you might run into active versus inactive relationships. A model can only have one active relationship between two tables, and that's the one used by default. But what if a single sales table has both an order date and a ship date, and you need to relate both of them to your central calendar table? Well, you create an inactive relationship for one of them. This is a total lifesaver. It allows you to manually activate that relationship within a specific DAX formula using the use relationship function, which lets you toggle between evaluating order dates and ship dates seamlessly. Next up, Section 4, Mastering DAX Expressions. Interviewers absolutely love this distinction. Calculated column versus measure. A calculated column computes row by row during your data refresh and is physically stored in your table, meaning it increases your actual file size. A measure, however, is calculated completely on the fly based on whatever filters the user happens to have clicked on the report at that moment. It doesn't take up physical storage space. The golden rule here? Rely on measures for aggregations like total profit, and only use calculated columns when you absolutely need row-level static tags to use in slicers or chart axes. To truly wrap your head around measures, you have to understand filter context. Filter context is exactly what it sounds like. It's the environment of filters surrounding a specific data point at any given moment. This includes the slicers a user just clicked, the specific row they're looking at in a matrix table, or even filters applied over in the side pane. If you understand that a single total sales measure dynamically recalculates its math just because someone clicked a new region on a map, then you completely understand the magic of filter context. So how do we manipulate that context? This is often the trickiest part of a technical interview, where they ask about the al accept, and all selected DAX functions. Let's break down exactly how we control this filter context. Looking at how we control this, the all function is basically the nuclear option. It completely removes all filters from a table, giving you a true, raw, unfiltered grand total. All accept does exactly what it says. It removes all filters except for the ones you specifically name. And all selected is probably the most nuanced. It respects external filters, like a user's choice on a page slicer, but it ignores internal filters, like the rows of a specific chart. Honestly, think of all selected as the secret ingredient for calculating a percentage of a total that dynamically updates when a user changes their regional slicer. Moving to the front end, Section 5, Visuals and Interactivity. You will almost certainly be asked the difference between a slicer and a filter. Ultimately, it comes down to the user experience. A slicer is a highly visible interactive button or dropdown sitting right there on the report canvas. A filter lives tucked away in the side pane. While users can interact with filters if you allow them to, filters are primarily there for the developer to enforce data roles silently behind the scenes, like setting a page-level filter that ensures only active customers are ever shown to the user. Basically, slicers are for exploration, filters are for governance. When it comes to displaying that data, you need to know the difference between a table and a matrix visual. A table is flat and two-dimensional, it just lists rows of data. A matrix, however, is essentially Power BI's version of an Excel pivot table. It supports both rows and columns, which allows for really nice hierarchical grouping. If you ever want to show sales by region on the rows and break it out by year across the columns, you absolutely must use a matrix visual. Finally, Section 6, Optimization and Security. When we talk security in Power BI, we mean row-level security, or RLS. Static RLS is pretty simple. You create a role called North Region and hard-code a filter for it. But dynamic RLS? That is where the real power lies. Dynamic RLS uses DAX functions like username tied directly to a security mapping table in your data model. So when a user logs into the Power BI service, it checks their email against the mapping table and filters the entire dataset automatically just for them. Dynamic RLS is an absolute game changer because it prevents you from having to manually create 500 separate security roles for 500 different sales reps. And now we arrive at the ultimate interview question, the big one. How would you design and explain a full dashboard project from scratch to a business stakeholder? This single question perfectly summarizes everything we've just learned. So let's piece this whole mental model together. You want to explain it to them as a journey. Step 1, understand the business KPIs and locate those data sources. Step 2, extract and clean that raw data using Power Query. Step 3, load it into a highly efficient star schema data model, making sure to always include a dedicated date table. Step 4, write dynamic DAX measures for your calculations. Step 5, build out an interactive report with visuals, slicers, and apply your row-level security. And finally, Step 6, publish the whole thing to the Power BI service and schedule your automated refreshes. So the final thought I want to leave you with today is this. Mastering Power BI isn't about memorizing 50 specific buttons to pass a test. It's about confidently navigating data through this exact end-to-end lifecycle. So looking at this process, which part of the lifecycle are you going to master next?